In this tutorial, we are going to learn how to write a proportional line follower. Um, we have seen how to write a simple line follower, and we also learned that simple line followers cannot do all kinds of turns or turn both ways. They work really well with just really small turns and straight lines. Um, writing a proportional line follower is not that hard, but tuning it requires some practice and understanding of what's going on. So let's start. So we are going to do this together, and I have not edited this video in the hopes that you understand how the process in which we kind of fine tune it. So the instances where it doesn't work, I have not edited it out of the video, so you understand how to tune a proportional line follower. Let's start by making a variable. Let's go to the variables tab, make a variable called target value. So we are going to say target, and we know from experience that my robot is connected here, but between from this Scratch simulation that the value is kind of between black and white, and mostly it's between like 50 to 70, and when we go on the black hand side, it can go as low as 20, and on the completely white it goes to 99 or 100. Okay, so that's what we need to know. Target value is about 70 in our case. So let's go back to our Spike programming and set our target value to 70. We are going to write a proportional line follower, so the gain that we need to see here is going to be kp. So we'll make a variable and make it kp. This is the convention of calling this thing this gain as kp. We are going to set our kp to begin with as 1. When you turn this on and off, it kind of keeps track of your display. So let's say our target is 70, our kp is 1. Now we need to steer our robot depending upon what is the error. So here I have made a sheet. So here, if your reflected light intensity, and I have entered all these values and I have put in formulas here so we can see what the correction kind of looks like. And we have set our gain here, we can set it to 1. So let's say our target value is 70 and the reflected light intensity at a certain spot is 80. So then our error is 10, our gain is 1, and so our correction is 10. So meaning if it's white and then we are turning 10 degrees to the right, which seems correct because we're going our robot is veering to the white side, so we are turning a little bit to the right. So this correction or direction seems right. So let's go back to Spike Prime and set our steering block. To do that, we must go to control and say repeat until, and then here we are going to steer our block. So let's make way to more movement motors, and no, let's go to movement motors, and then here we want this block which says start moving in this direction. So where it says right 30, it's basically like a steering wheel. So if you're going at 0, you're going straight. If you're turning right, it's a positive value, and if you're turning left, it's a negative value. So whatever you put in here, that's the way your robot is going to turn. Now here's where we're going to do a little bit of math. So first we calculate our error. Now we know from writing a simple line follower that the error is reflected light intensity of f minus target value. So we'll go to sensors, pull out this reflected light intensity, turn it to f, and then go to operators, use a subtraction block, and then add this here. For putting target value here, let's go to variables and add target value. Okay, so this is our error, and now we must multiply it by the value of kp. So back to operators, pull out a multiplication operation here, and insert this here, and this other side is going to be kp. Go to variables, pull out this block called kp, and insert it here. Now this is the way a robot is going to turn. We want this to run for a certain duration, so let's go to sensors and use the timer function. So let's reset our timer and check if this timer value is greater than some value. So let's put this, so till timer is greater than, let's say, 20 seconds. So we'll put this here, and now we are ready to see how it works. So you might remember from our previous examples that just doing this much is not going to be enough. Anytime you use movement motors, you should go to my blocks and use this move motor function and initialize it. You can use the distance 0. Make sure you're connected and download your code. And you kind of see it went off course and it's like going everywhere, right? So you can see that it traced the curve well, but then at some point it lost track of value, and maybe it didn't stop, like it just kept going. I had to stop it from here. So what are we missing in our code? We didn't add a stop movement block, so we should go to movements and then add a stop movement block here. Okay. Also, another thing that's happening is that maybe our correction is not quite enough for this robot, but we have added a stop moving block, so let's try this one more time. Alright, I have reset my bot to the starting position, and now we're going to download our code. You can still see that it's kind of doing more of the same. So what I'm going to do is, we want our correction to be much more sharper. So when it kind of veers off course, we want it to correct quicker. So what I'm going to do is increase this gain, and I'm going to make this 1.5 and then start over again. Okay, the robot is reset. So you saw that it did a little better with this increased gain. So we're going to take that as a clue and increase it still further to, let's say, 2.5. Okay, and then start over again. Starting again. So it needed to start one more time. Now we want to try a different strategy. So the gain seems to be okay, but the robot seems to be moving really fast. So in our move motor my block, let's go out here and see that our movement speed is 40%. So it's kind of fast for a line follower. So it needs time to kind of sense the reflected light intensity and kind of correct. So we need to slow down our robot a little bit. So I'm going to use this block to set our movement speed to a slower value, and I'm going to make this 30%. Okay, let's see if this changes our performance. And so you can see it is getting a little bit more time to correct its course because it is inherently going slower. And now you can see it's able to do a much better job in tracking the line. In a robot game, we want our robot to always be able to do multiple missions. So I understand the desire for teams to, like, make the robot fast. So you can play around this value a little bit to see at what is the maximum speed at which it can accurately track a line. So I've changed it from 30 to 35, and see if it performs just as effectively. So clearly at 35 it's losing track. So we are gonna switch back to 30, and we want to try this one more time. And you can see it's going zigzag because it's trying to find that target value of 70, and then sometimes it will still lose track of the line if the gain is too high. So maybe we can reduce this gain slightly less so it's not over correcting. So we have reduced our gain to 2.4 now, from 2.5. I will reset my bot, and now we want to run our code. So watch carefully where the line follower is spending most of its time. Is it falling on black? Is it falling on white? And as you saw, that it kind of lost track for a little bit, but then it again caught up with the line. So that's a good mark of a line follower. Now here's the thing, you could play around with this target value a little bit. So is 70 a good value, or should it be 65? It depends on what are the light conditions in your room, or when you go to competition. Now many teams will ask me this question like, hey, can you give us the values right away? So that's the thing, I can't, because it depends on your situation. And so this is important for you to understand that how did we arrive at this KP value, the target value, and how are we tuning our line follower is very much dependent on what's the speed of the bot, what are the light conditions and such. And that's what the judges want to know at the first Lego League competition. How did you tune your line follower? So these values you gain, you kind of find out by experimenting and running your robot. So please be sure to like try out different values before you arrive at the one that works for you. So again, I've set my bot to the starting spot. This time we're trying out the target value of 65 and a gain of 2.4, and let's see how it works. And you can see that it effectively reached the airdrop. So do you think it'll be able to reach unload cargo? So it reached right up to that point, and then it couldn't turn inwards, but maybe we could have tried out the outside line, like the right hand side edge. Now that we know that our proportional line follower works well for these values, we can now turn it into a My Block. So make your way to My Blocks tab and click on Make a Block, and then call this proportional, P for proportional line follower. And it's gonna take in time in seconds. You can add a label, time in seconds, so you know what you are adding in here, and then you can attach it here and move this time in seconds to this value so you can run it for a certain number of time.